Thank you. So good afternoon, everyone. And today I'll be presenting Gorilla, which is a joint work with my collaborators, and Tianjun and I lead the project. So let's look at the state of the world today. When you need to use an LLM, you as a user are at the center of the task, where you might go ahead and use your chat completion API or use just your UI and then talk to the LLM, right? So you prompt the LLM, it gives you a response, and then you take this response, and it's up to you to go and perform some action on the world and then see how the world responds, right? So fundamentally, you're going to perform the action, and then you're going to get the response back. I've shown this as zero-shot interactions, as in one back and forth, but you might have multiple back and forth. But fundamentally, the burden lies on you to interact with the LLM, get the response, perform some activity, and then get the response back, and then basically relay information to and forth for the LLM, right? So this is how you tend to use the LLM today, and there's one too many LLMs to choose from. Now, what we want to do and enable is actually flip this and say, what if you are on the extreme end? What if you go on the left-hand side, and then you talk to the LLM by asking the LLM, hey, look, I want to do X. So you're prompting the LLM, and now the LLM is going to go and perform the activity on the rest of the world. And then you get a response, and then you relay the response back to you as a user, right? So this is the vision that we want to enable. This is all too abstract to ground this in one example. We're all machine learning researchers over here, or we use it in some sense. And today, the most scarce commodity is GPUs, right? So say, suppose you were to ask the question, hey, can I get an 800 GPU in East US? Now, this is the prompt that you give to the LLM. And what you want the model to do is go ahead and do a bunch of things, right? One is read the state of the world. OK, does this user have quota on your favorite cloud provider? Two, on this particular region, is there availability for this particular GPU? And if so, return that back to you as the user. So we don't want you doing this, where you go and ask, hey, how do I get this? It gives you a bunch of commands, or it tells you what to do on the UI, and then you as a user go and do this on the UI. That is not what we want. Can you just talk to the LLM? The LLM performs the activity on the UI, and then it tells you what's going on, and you can either accept or reject the response that you get. So why is this? Is because humans are good discriminators, we're not good generators. So let the generative AI model, which by definition is generative, do the generation task for you, and you just discriminate and say, hey, do I accept this response or do I reject this response, right? So that's the idea over here. So in this case, the LLM that we have trained is called Gorilla. So you basically invoke Gorilla, and then Gorilla recognizes that, to give you a GPU, in East US, I'm going to use Azure. And then I'm going to give you back the SSH access to your particular GPU. Now, so this is an example of how you can invoke an hyperscaler, but obviously there are one too many APIs that you might want to use. So this remote clicker works stochastically. Sometimes it does, sometimes it doesn't. OK, there you go. So similar to one example of hyperscaler, suppose you say, hey, look, I want to do X. And then you teach your Gorilla model to call the APIs to do X and then return the response to you. Now, the obvious question is why APIs, right? So to tell this, let me tell you how we started with the Gorilla project. Sometime around November and December of last year, as LLMs came to the scene, and we were early adopters of ChatGPT like everybody else, one thing we realized is that chatting is great demonstration of the tool, but it's not something that you might want to do on a day-to-day basis, right? Like here, you're sitting in a talk to get information. It's not too great if I start chatting with a few of you. And during lunch or during skiing, you might want to chat, but to get work done, you don't want to chat, but you instead just want to use a tool to get work done. So GitHub Copilot is a good example, right? Rather than chatting, you ask it what needs to be done, it gives you the code, and you're done. So what does this mean? An LLM is a powerful tool, but a tool nonetheless. And one thing we know is that the way you augment tools to be more useful is by connecting it to other tools. Right? So it's only when you connect tools together do the tools become more and more powerful. Well, that's great. So how do you connect tools in computer science, right? And so the answer is, in computer science, when you have different computer systems, the way they talk to each other is through API calls. APIs is how different computer systems interact with each other. That's the promise and the return interface, right? So that's how we thought of building Gorilla. OK, look, a lot of people are saying, hey, we want to connect this. We want to do a bunch of things. Can we now just teach the LLM how do you invoke APIs? And by doing this, you're training the LLM to use other tools. And this was the thought process. We are trying to write a machine learning paper, so we start off with Hugging Face, TensorFlow, and PyTorch APIs. And then we realized it's not very many people who call Hugging Face APIs on the daily outside of machine learning researchers, right? But we got a lot of feedback from users saying that, hey, look, we use Kubernetes on the daily, but that's so hard. There's so much going on. Can you help? Can you, give us Gorilla that's trained to use Kubernetes calls? So since then, we have gone ahead and added some more APIs. There's more and more that we're adding where you can just talk to the LLM, and the LLM is going to call the APIs for you. So great. So that's all talk. Before I proceed, let me just show you a quick demo so you know that this actually works. So once you teach an LLM to call APIs, you can hopefully this is visible. So once you teach an LLM to call APIs, you can wrap this in different form factors, right? So one form factor here is the CLI tool. So for example, I can say things like, Gorilla, list all my GCP instances. So what we do here is go ahead and actually go and call Gorilla, and then we show you a bunch of options, right? So then you pick which option you want. Let me just go with the first one. So now this runs this API. So this is like a command line API, and then returns the response for you. So I have a bunch of VMs running, so on and so forth, right? So this is one modality. Now you can use the same model, but wrap it up in another different form factor, which is how do I integrate APIs into my workflows? So here's an example where we integrate this with LangChain, which is a popular workflow manager. And so the interface is pretty simple, right? So some of you may have used the chat completion API. All you do is instead of hitting their endpoint, you hit a small box that's sitting in Berkeley. And then the question you ask is simple. Look, I want to translate from English to Chinese. Go. So what Gorilla does is it responds with a bunch of API call, and to make it more usable, we also give some additional information. So this is a natural language processing task. Here's the API call. This is provided by this particular API provider, which is Hugging Face in this case, some interpretability explanation. And then this is basically the code, right? And the best part about this is you can just execute this code. This is a simple exec call that you do. And what you get as a response is the translation of what are the differences between renewable and non-renewable energy resources, right? So this is one example where, look, you can ask an LLM to do this for you, translate X, but how do you know it hallucinates? How do you know it's exactly what you want it to be? Instead of that, there are tools today that can do what you want to do very precisely without hallucination, so why not just invoke those tools, right? So you use your LLM for the reasoning task, for all the good things that comes with it, but when you want more clear and deterministic responses, just use different tools that do that for you. And this is one, and I've hopefully shown you 2 examples where you can wrap around your API calls in different modalities and form factors that you would need. So by the way, the demo that I showed you is live. You can scan this, or just go to our website and we'll link you. Hopefully, all of you won't try at the same time and break it, but yeah. So now I've shown you that it works. Let me actually go and answer what enabled this, right? So what are some of the interesting research questions we had to solve to enable or to teach an LLM to use APIs? So the first question, and I think this is probably one of the big questions for all of you who are trying to use LLMs, is how do you mix fine-tuning and retrieval, right? What's the wisdom of the crowd? Great. That is not intended. But that's OK. OK. So the hypothesis today is that fine-tuning is used to augment the behavior of the model. And by fine-tuning, I'm referring to both the instruct tuning and RLHF. And retrieval is what you use to introduce new knowledge to the model, right? So this is when you have out-of-domain information, or when you want to introduce freshness of data into the model. But what we really find is that fine-tuning is actually remarkable at both behavior and inducing knowledge into the model. Except you still need retrievers because they help, they help ground the LLM, especially when you don't want it to be wrong. So you can say, look, I want you to use this piece of information to answer the question to me. This is even more critical if you're trying to serve an LLM from your proprietary data, where you may not be comfortable fine-tuning, but can you give it as a retriever? Except there's one thing that we know from the recommendation ranking systems is that retrievers are actually pretty bad, right? How many of you all have heard of BM25? I see a few hands go up. That's like the working house of retrievers, right? How accurate do you think BM25 is? OK, so I need to ground this question. By accuracy, I mean recall at k, which means if I were to give you k options to retrieve the answer, can you be right at least one of the k times? So people typically do recall at 3, recall at 5, recall at 10, so on and so forth. And one thing that's well known outside of LLMs is that retrievers are actually pretty bad, right? So retrievers are like maybe 50%, maybe 70% accurate. It's your re-ranking that makes it better, but you can never be too good at building a retriever. If you were to build a retriever that's like 99% accurate over billion scale, then you basically built the next Google, right? So retrievers are bad, so then how do you solve it? Now, to answer this, what we came up with is this solution called Retrieval-Aware Training, right? So the key takeaway is pretty simple. The idea is you want to fine-tune the model to use or ignore the retrieved context, right? So you ask a question, hey, I want to do X, the model comes up with an answer. You need to implicitly make this one-bit information, is this relevant to me or is this not relevant to me? If the retrieved information is relevant to the LLM, then use it. If the retrieved information is not relevant to the LLM, then just discard it, except this is implicit, right? So I'll give an example, and hopefully that'll make it more clear, but that's the simple idea. And the way you train this is by introducing both correct and incorrect retrieved results during instruction fine-tuning. So the takeaway is your retrievers are going to be inaccurate. Take the BM25, which is popular, or take like, GPT index or whatever retrievers that you want. It doesn't matter if your retrievers are stored in a vector DB. It doesn't matter if you use FIS, NSFW, HNSW, et cetera. It doesn't matter what similarity search that you use, but fundamentally, your retrievers are going to be inaccurate. Can you teach the model to be robust to that? So that's the high-level idea. Right. So in short, there's been a lot of debate where some people may use fine-tuning. Some people are like, hey, fine-tuning is not very relevant. I don't want to give cloud providers or language models my data. So then some people say, hey, use retrieval augmented generation, RAG-based techniques, but this may not be accurate either. And some people say, hey, can we actually balance the two? What's the question? And we say, don't even do that, right? You can't pick one or the other. And if you're trying to balance the two, that may not work. Instead, do what we call is the retrieval-aware training. So here's an example to help understand that better. So the user prompt is, I am an engineer at Uber, and I need to find an API that can classify pedestrians, cars, et cetera, from an image of the scene, right? Simple. Self-driving car, tell me if there are people or if there are cars. Now, you can use RAG. So for those of you who are not aware, RAG is where you take the question, go to your vector DB, find the most relevant documents, and stick it in as a part of your prompt. And when you use RAG, I've shown top k where k equals 1 over here. It says, hey, look, this looks like an object detection task. Seems reasonable. Why don't you use the hybrid nets model, right? So what the LLM is supposed to do is first ask the question, is this relevant? Is this API that I retrieved relevant for the user prompt? If it is, I'm going to use that and then respond to the user. On the other hand, if the retriever gave you, in this case, a neural machine translation API, then it's not if you want to do object detection, a translation API is not going to help. So here we teach the LLM to answer this question implicitly. Look, this retrieved document looks inaccurate, so I'm going to discard it, and I'm instead going to use the information that I have as a part of my pre-training or fine-tuning phase, right? So it's simple. Retrievers are inaccurate. Teach your model to be robust to it. Before I move on to the next part of the talk, any questions on this? Yes, question.
Could you retrieve maybe 1,000 samples and then pick up the best of those using this system?
Yeah, great question. And so to repeat the question for those of you who couldn't hear is that can you, instead of doing top 1, pick top 1,000, right? And hope at least one of them is correct, and then give that to the LLM. And the short answer is yes and no. Yes, in the sense there's been some work that shows that pick 1,000 and then re-rank it by some other metric and then give that to the LLM, right? But no, because of 2 reasons. One, it's been shown that the more and more documents that you retrieve and give it to the LLM, the more and more you're confusing it, right? And you cannot guarantee that at least one of those 1,000 has your answer. Basically, you don't get 100% recall, right? And there's a third practical aspect of it, which is the more documents you give, you're running out of context length. That becomes especially acute when you do some task like this, right? Because there are 101 machine learning models. And the constraint will tell you what's more critical, right? For example, if you say, hey, can I run this on a Raspberry Pi? You probably can't run this. You might want to use a YOLO V5 or some of the smaller models. But if you say, look, I want the top 1 accuracy to be 96% on ImageNet top 1, et cetera, then probably you want to use some of the vision transformer style models. So yes and no. Yes, you can try to improve the percentage by a few percentage points, but you're not going to be 100% accurate, right? Does that make sense? Yeah. Okay, I think there was another hand there, and then I can come to you.
So the question is, what evaluation metrics would you suggest to evaluate this type of RAG-based frameworks?
Yeah, so a lot of the metrics today, it's a good question. We don't have clear answers, but the closest answer is from the recommendation and ranking community, because that's where you typically have K documents. The user comes with a question, and then you try to match it. And so recall at K seems to be a good offline metric, right? Obviously, you may not have offline metrics all the time, and if you have the benefit, then you have click-through rate and a bunch of other metrics. But typically, recall at K is a good offline metric to optimize over. I think I can take one more question before I proceed. Yes.
Yeah, so I understand the motivation, but it seems to me that by training the model to ignore irrelevant context, it makes it more susceptible to hallucination. And instead of making the model ignore context that it finds irrelevant, shouldn't we improve the embedding model to make it return more relevant context?
Great question, for which I have the next question for you. How much does GPT-4 hallucinate?
Out of the box.
Yeah. Suppose you just use the GPT-4 0613 or any of your favorite checkpoint models. But there's a generic question, right? If I were to ask you, how much do LLMs hallucinate? Is there an answer? And the answers I've heard is mostly, oh, a lot, not so much, works for my task, more than 3.5, less than llama, so on and so forth. But these are, it's not a very scientific metric to work with, which also comes to your question is that how do you solve something when you can't measure it? And so the first thing that we want to do, which we did with Gorilla, is give a framework where you can actually measure hallucination. Now, I want to preface this by saying is that this works great for API calls. It could be generalized to a few domains, but it may not generalize to all the domains, right? Like, for example, sometimes the prompt is not accurate. If I were to ask, when was Michael Jordan born? Well, is it Michael Jordan, the basketball player, which most of you might be thinking? Or if you're from Berkeley, is it Michael Jordan, the professor of machine learning, right? So it's hard to tell even for us as users, but given the API domains that we have, it's pretty easy to, not easy, but we have a technique to measure hallucination, right? So how do we do that? The technique that we use is something called the AS tree subtree matching, right? The abstract syntax tree subtree matching. So suppose the API that's generated is the following. It's torch hub load, PyTorch vision, densenet 1 to 1, pre-train equals 2. It doesn't matter if you know this API or not, but this is basically an API that exists. The first thing that we do is we go ahead and we build a syntax tree from this API call, right? And this includes all the arguments. The next thing that I do is ask a simple question. Is this API a proper subset of my universal set of APIs? Now, we can do this in APIs because, look, if you're Stripe and you expose a bunch of APIs, you only have those APIs to work with. A user cannot come up with a new API to call, right? As a service, you know upfront what APIs is available. And unlike a lot of other domains where there's been a lot of legal concerns on, oh, can I use this data, can I not use this data, the incentives are very well aligned. There is an incentive for Google Cloud to let you know about their APIs because the more you use them, the more they make money. Right? So there's great tutorials, documentation, Swagger files, open API spec, et cetera. So you can use all this information to understand clearly what APIs is available, and then ask the simple question, is this a proper subset of this? And in this case, we find that it is. This is the brown part that I've highlighted, right? So you can see some minor implementation details like pre-trained equals true is not checked because that's an optional argument in Python. But you basically ask the question, is my API that the LLM generated a proper subset of what's needed? If it is, then it's not hallucinated. By no means it means it's accurate, but at least it's not hallucinated, right? If this were to say, use Ray hub load, then you know it's inaccurate, right? Ray does many other things, but this is not one of those. So that's how you know what's hallucinated, what's not. Great, so how well does Gorilla perform? I've told you the two questions we had to answer to build Gorilla. One is, how do you make it robust to retrievers? Second is, how do you measure hallucination? Let's actually go ahead and measure hallucination and see how Gorilla performs, right? So the prompt is simple. Help me find an API to convert the spoken language in recorded audio to text, right? And we know that there's a bunch of APIs to do that today. This is how GPT-4 performs, where it tends to hallucinate. Claude does not hallucinate. It comes with a library that is not the right task. with Gorilla, we are able to come up with a right API call. And if there's one thing that you need to know about researchers giving a talk is that all results are cherry-picked, right? And so this is no exception, so this is a cherry-picked result. So let's try to go and understand how well does Gorilla perform across the board. So over here, what you have on the y-axis is accuracy, and on the x-axis is hallucination. Lower is better for hallucination, higher is better for accuracy. Keep in mind, one does not imply the other, right? So if I were to ask, how do I receive money? If it says use the Stripe API, that's accurate. But if it says use PyTorch API, then it's not accurate, but it's not hallucinated, it's also not, it's not accurate, but it is also not hallucinated. PyTorch API exists. But if it were to say use Shishir API, then that doesn't exist. So then you know it's hallucinated, right? So you want to be lower and better. And what I show is, so we call this zero shot, where you ask the prompt, get a response. This is how you would use ChatGPT today. And you see that Gorilla performs better than most closed source and open source machine learning models. Now you can go ahead and augment this with a retriever. So the GPT retriever is state-of-the-art retriever today. And I also included the Oracle retriever to answer some of the questions, which is what happens if you improve the embedding model, right? This is when your recall top k equals 1 is 100%. This is if God gave you the right answer all the time. And this is to show you the headroom, right, and how well you can perform. And as you can see, across most techniques, including zero-shot, GPT, and Oracle retriever, Gorilla matches, if not beats, open source, but also more interestingly, closed source models like GPT-4, 3.5, and Claude. And since we have this metric, this also helps you answer a lot of questions that people. You saw this on some social media platforms, but it wasn't really validated, which is GPT-4 hallucinates more than 3.5. So you can for your task, sometimes you require more hallucination if it's like a generative AI task. Sometimes if you're trying to answer the question based on Q&A style, summarization, translation, et cetera, you might want to use less hallucination. So you can also use this as a metric to measure and determine which model you want to use. OK, so we're part of a research lab, and when we present research, we usually get a bunch of feedback. One of the feedback we got from practitioners is that, but look, APIs constantly evolve, right? There are some mature APIs that are GA'd, but for the APIs that are being built or in development, APIs evolve maybe weekly, sometimes even monthly, right? But how often do you train an LLM or even fine-tune it? Maybe once every 6 months, once every year. This is because even if you could afford fine-tuning LLMs, evaluation is so hard that you might think twice before deploying every new checkpoint into production, right? So to answer this question, what I'm going to show to you is that Gorilla is actually quite robust to changes in APIs, right? So here's an API that was used in the training. So over here, the user wants to do something, and the API that I have is .vision, FCN, ResNet50, pre-trained equals true. Also, let me just straight up apologize for the use of so many machine learning APIs. We were trying to write a paper, and this spoke to the audience. But you could replace this with Stripe, Salesforce, ServiceNow, Datadog, or any APIs that you prefer. And so this is the training time. It's quite likely that during inference time, as time progressed, they decided to update the backbone from ResNet50 to ResNet 101. Right? This is like V1 to V2. API version changed. And as you can see, because we have this retrieval-aware training setup, Gorilla is actually quite robust and captures this change in API. So we were able to serve the latest API to the user. Now, this is where the API version changes, but you can also have your repository change, right? So in this scenario, instead of using PyTorch, we have engineers at NVIDIA who are writing CUDA code that's customized for your task. So probably you can use a much faster and optimized model if you were to go for the NVIDIA repository. So basically, across changes in API versioning and changes in API repository or any other changes, Gorilla is able to adapt to changing APIs. OK, so I'll take questions at the end. Moving on. So this is the fun part, right? So when we open sourced Gorilla, we also went ahead and we made different platforms where you can access Gorilla. And we also have a Discord server. I would invite all of you to join. But the feedback has been actually quite supportive, right? And this is by far the best feedback I've ever received, which is this is the next best thing to sliced bread. I don't think it's there yet, but a lot of people are using it and finding it useful. It's not just a research artifact. We've also been on the front page of Hacker News multiple times by now. There's a growing open source adoption as well. But also more critically for us, both domestically and internationally, a lot of popular press and AI influencers and researchers in this field think that this is the right way to go, where you're trying to teach an LLM to use APIs and then have this as a modality to teach the LLM to interact with the world, right? We also have a hosted box from Berkeley, and where people hit our service and we give them a chat completion API. So it's basically give us a prompt, we give you an LLM generated response. And all of our models are Apache 2.0 licensed, so you could also use it commercially. And we have seen pretty healthy invocations since the 2 months that we have open sourced it. So with that, I'd like to conclude. So we have trained Gorilla, which is an LLM that writes API calls. And we're teaching an LLM to use APIs. You're actually teaching it to talk to the rest of the world through APIs. And this is an open source project from Berkeley. And we have an API zoo where you can contribute your APIs. If your organization has a bunch of APIs, we train models with it. So when users request Gorilla, we can serve your APIs to them. And this includes RESTful APIs, GET POST, GraphQL APIs, SQL APIs, so on and so forth. We are pretty agnostic to that. And this is an open source project, so if you're interested in contributing, then please do join us and help us build Gorilla. Thank you very much, and I'm happy to take questions. Yeah.
Thank you, great talk. I have one question. So what if I wanted to use Gorilla for my private application with my private APIs? How can I teach it?
Yeah, so that's a good question. And this has also been a very growing request where, it's like, if you're an enterprise and you have a bunch of APIs, can you teach the model on your APIs that serve to only your set of users within your enterprise? So we have a bunch of pilots going on, so I'm happy to talk about it, but it's fundamentally possible. We have open sourced our pipeline, so you could, well, it's in the paper, so you could do this today, but if you need any help, we're more than happy to collaborate and also try and see how that works. Because what's challenging is A, how do you train the model, and B, how do you serve the model? And in both of those areas, we have expertise. So at least as an academic lab, we are happy to collaborate and help along those lines. Yeah. Questions?
So typically, when we do retrieval-based methods, when we do information retrieval, right now we do a lot of contractive training just to disambiguate similar APIs, similar API definitions. So do you have anything do you have any thoughts on doing that? Since, let's say, if I remember in the paper, you train on Hugging Face APIs, and there's hundreds, or if not dozens, of very close and similar APIs. So have you thought about how to disambiguate the API calls and the efforts there?
Yeah, so that's a good question. The question is, if you have multiple APIs that all look and feel very similar, how do you disambiguate between the two? And there's two answers to this, right? One is you can do this at the retrieval phase, where you say, hey, look, I'm going to try to train the model. There's been a bunch of work on that, but I feel like we are hitting the seams, if not at the seams of what retrievers can do. But there's a second part of it, which is, can you now have a compact enough representation, build the retriever, and then use your LLM to actually discern if it's right or wrong, right? So you can have two models that look the same, feel the same, but one has slightly better performance over the other. Maybe this one is faster inference than this one. Then you can understand the context. So when the user says, look, I want to do this on a smartphone, well, then probably you want a smaller capacity model because you don't have the computing power, versus doing it on a server class GPU. So using the LLM to discern the performance benefits or more intricate details is probably a good idea. And you just let your retriever enlist the set of relevant candidates is one way how I would think solving it. But otherwise, it's there's nothing much you can do actually, because you're going to probably increase your embedding size by k, but you're playing with a few percentage points here, not really big differences. Yeah. Question. Yeah, I can probably just shout it out. Yeah.
The notion of this AST tree and submatching, that's more in the crux of the thing. Do you see this expanding to document retrieval and answering questions?
Yeah. So to repeat the question, is using AST subtree matching to measure hallucination critical? Can we think of extending this to documents, etc.? And the answer is yes, because I think this gives a neat framework, right? But at the fundamental is, can you have a universal view of what's available? With APIs, it's simple. If Stripe says, here's my set of APIs, there's no more until they come up with new ones, right? So if Ray says, here's the set of APIs that you use, you have no more. So that's clear. For documents, it's hard to tell, right? Like every web page on the internet is a document, so it might be tricky. But if you're like an enterprise and say, look, here's my set of documents, you can then use to ground that and say, I want your response to be only from this subset. So I think AST gives you this neat, like a handy tool that you can use to measure hallucination. But how do you apply it out of the box documents, I think requires some more thought.